Hi guys, this is your embedded friend, and today we're going to talk about 7-segment displays, 1-digit 7-segment display, and 4-digit 7-segment display. I'll show you basic principles for 1-digit 7-segment display using only electrical current. As you can see, I have already attached it to the breadboard. The only problem is that my 1-digit 7-segment display has one pin damage, and that's why you are not seeing this segment on. But either way, you'll understand everything else based on my explanations. Basically, we are having the datasheet here. It's a common cathode, which means we are applying positive current on segment pins if we want them to be on, and pins 3 and 8, which are common cathodes, are grounded either way. So basically, if we were to have this other way around, that it would be a common anode, then pin 3 and 8, there would be always applied some kind of current, and you'll have to basically drive ground the segment pins so that they would be on. And if we look at our 7-segment digit display, here we have an pin we have a segment B not working, which means pin 6, this one, isn't working. And if we are, for example, were to remove a resistor from pin 5, which is responsible for digital point in our datasheet, then we would turn it off. Another example, let's look at the datasheet again. Let's take segment G, that's pin 10. Here's pin 10, here's pin 10. It's the last one. Here we removed pin 10. Oops, that's not good. But you can see that G, which is the middle segment, is not working. So let's move on to the 4-digit 7-segment display. Basically, we are not having multiplications of pins for each digit. This way we would have a lot of pins, which is really unnecessary. And how they come up with it is that basically segment pins are shared, and there are 4 pins for each digit, one pin for one digit, basically, and based on either you have a common cathode or common anode display, you'll be driving your digit pin high or low to basically turn it on, and this way you'll have to drive your segment pins as you desire to basically write to this digit, and then move to the next one, turn off the previous one, and turn on the next one, and again write to segment pins the same value, maybe the other one, and you're basically going in the loop, always writing to the pins, and it's not necessarily visible to the naked eye, and that's why we are seeing each digit on. I found a library that you can use. Here's an article. I'll put the link down in the description. Yes, about the resistors for yes, basically always look at the datasheet, but usually if you're having 3 or 5 volts applied, you'll need 220 or 330 ohms resistor for the displays, and you can take a look at this article, but here we have a GitHub page for this library, which I find more useful because the configuration is different. What I find not necessarily good about this is that the person who wrote this did not attach the datasheet for the display they are using. They've mentioned that they're using some kind of an eBay display, and this is not really acceptable in my opinion, because even though usually you'll have pins from one on the left down corner to pin 6, and then you go up right pin 7, and then up left pin 12, but you can never rely on those type of things in embedded world, so I think we should always look at the datasheet because you never know. And so I found the datasheet for which is really close to the one display that the person is using. They're using a common anode display, and so I was able to understand that the pin configuration. You can see how the common anode is working. Basically, the current is going from digit pins to the segments. Me, on the other hand, I'm having a common cathode display. How do we know that? Is that if we look here, the current is applied and is going from segments to digits basically, and yes, I've written a simple program for demonstration purposes, which basically I've added some buttons here. They're corresponding from right to left to the numbers, and if I press the button it increments the corresponding number, and if the lower number is overflown, the higher number will be incremented, as you can see. course some software um, button uh, how do you say it? The button basically so that it won't read multiple writes when you're pressing the button. The debounce mechanism. Yes, the software debounce mechanism for the button. And yes, it's pretty much it. I've added some serial output to debug it. We are basically using POW because we are moving on in these digits, and I'm adding 0.5 because POW is the floating point output, and we have to basically cut it so that it's precise. And for demonstration purposes, I've also created this program. Let me just change this one. Basically what it does, it doesn't have any library, and it in normal situation it outputs just the number I want that I put here in the function in the main loop. We have here some mappings, some configuration for the segments. Here are the segment pins, and here are some helper function. This is a simple one. This sets the segment, enables digit and writes to the segment, and you can change if you are having common cathode or common anode. Here if you have a common anode, just put it to false. Maybe I'm missing some configuration, but I think that should suffice. It's rough, I know, but that's not the main point. The main point is that, let me change this for better visual, and we put it to true, and basically I'm incorporating delay between each write to the digit pin, so that you can see that here, let's take a look. It's always changing in sequence in my main loop. Sometimes it's not visible to you, but it's just the camera. I don't know why. Maybe I have too much lighting. It's not so bright, I would say. And yeah, that's it. You can play around with it, see it for yourself. I hope this was useful. Put the comments if you have any questions, and I'll try to explain and answer them as best as possible. And I'll see you later. Bye.